Hey guys, Colin here, hope you're well. So today we're going to take a look at WannaCry, which is the rather infamous ransomware sample, which caused quite a stir across the globe a couple of years ago. It's a pretty interesting sample to analyze, but I wanted to show you, using this sample, just some basic tools and techniques that you can use across any malware sample to get you going with your static analysis and also your behavioral analysis. So we'll talk about some tools and techniques that you can use and environment as well. So WannaCry is pretty interesting. Obviously, it's a ransomware variant and it has a ransomware module, as you would imagine, but also has a network spreading capability as well. So it will use your machine to try and propagate around the internet in order to further infect other people and also around your local area network as well. In both scenarios, it tries to use the Eternal Blue exploit from the NSA, which is the rather infamous hacking tool which was dumped by the shadow brokers a few years ago. So quite an interesting sample, a lot of stuff going on in there. And there's a lot of activity for us to get our teeth into. So it's a good one to kind of showcase some of the tools and techniques that you would use in order to analyze malware. First thing I tend to use is PE Studio. This is a great malware initial assessment tool. So the first thing it does, it gives you like some virus total indicators. It also gives you like the file headers, the libraries, the imports. It's useful to determine whether a binary might be packed or not, because it's probably going to have fewer imports if it is, but you can see here there's plenty of them, and you can get a feel for potentially what the malware is going to do just by the API calls that it's going to use. So there's some stuff here about sockets, and that's going to create some kind of connection. There's some stuff about cryptography, so maybe there's some random, so maybe there's a random number generator, create service, open service manager, etc. So maybe there's going to be a service involved. So if we didn't know what this binary was doing, we got a fair idea just by looking at some of the API calls what might happen. Resources, we can see here there's an actual executable resource in this binary, which makes up 94% of it. And we'll see why in just a second. Version information, strings information, all really good stuff for you to get your teeth into in order to assess malware. What we want to do, what I tend to do first, is just run some monitoring tools. And so I run Process Hacker. You can run Process Explorer from sysinternals, basically the same thing. Just gives us a live view of what processes are going on the file system at the moment. Also, Process Monitor, I look for processes being created and processes exiting as my default filter, but we can use other filters as well. And that just gives us a nice kind of historic view of what occurred on the machine from a file system, from a registry, and also from a network perspective as well. Also from a networking point of view, I like to use DNS Query Sniffer, which is from Nursoft, so just tell it what adapter to listen on. And it will give you a nice timestamped view of all the DNS requests and the associated responses on your machine. So that's pretty useful. Leave that running. And also, most people tend to use Wireshark, but I tend to use Microsoft Network Monitor just because I'm lazy and I can't really get my head around Wireshark filters, or at least bring myself to remember them. So this kind of makes it easier for me, and also shows me the processes generally that were responsible for the traffic. So you can see the system process was responsible for whatever these requests are. And as we generate more requests, you can see SVC host, for example, is responsible for these requests, and you can actually filter out by the conversations automatically. Saves you even writing a filter when I can't be bothered. So that's nice. I can see what processes generate the traffic. So let me just we'll kind of clear these off. Press Control and X to go from a kind of clear state there, and also here we can just press the erase key and just go from a clean state in Procmon. And let's run the malware, see what happens. So I run it. I did double click it. I didn't see anything in Process Hacker, but if I go to Procmon, you can see that WannaCry did actually launch, but immediately after it exited. So it probably did that so fast that Process Hacker didn't really register it. And the reason it did that, if you have a look at the DNS requests, there's quite a lot of stuff that's going on my machine anyway. But you can see this one here is a bit weird, right? And it's got a green light next to it, and I'll talk about that in just a second. But this host name, to the malware tried to reach out to, and I wonder whether in Network Monitor probably didn't capture it either. Probably didn't have a chance to capture the host name, so maybe it's unknown or whatever. Let's have a look in here and see. Yeah, so we've got a GET request, and you can see here that to this stupidly long domain. But let's go back to the DNS view so you can see it a little bit easier. So we did get a response back from the DNS request, and this is what's known as a kill switch domain. So many of you will know that the WannaCry ransomware was kind of curtailed in its global infection rate because of the actions of a certain individual called Malware Tech Blog, now infamous security researcher, who identified that the malware was calling out to this domain by way of a kill switch check. And what I mean by that is the malware is looking to see whether that weird host name has actually been registered. And if it has been registered, it won't actually infect you. So if it gets a positive response back from that DNS check, it's not actually going to infect you, like we've just seen now. The malware exited. I'm not actually infected with WannaCry. But at the time when the malware was released and was propagating through the internet and across organizations across the globe, for a good space of time, a week or two, that the malware was really, really prevalent, this domain was not registered, and therefore that meant that the malware would infect you. But with malware TechBlog activating the kill switch, if you like, by registering that domain, it meant that the malware would not actually infect any further. It might still propagate, but it's not going to infect any further. So that's really interesting. So what we actually have to do in our environment here is trick the malware into running. I'm just going to stop the capture of these events because Procmon is quite heavy on my virtual machine. So if we load it up in x32dbg, so I'm using a 32-bit debugger here, a 32-bit virtual machine, hence the reason why I'm using a 32-bit debugger. Press F9 just to get to the main module. When you load a binary into x32 or x64, whatever you want to call it, first thing I tend to do is two things I tend to do. One of which is look in the current module for string references. And what we're going to look for, this is a really good way of finding a jumping off point for where you should start analysing malware. Pretty much no one is going to start at the entry point and work through line by line to see what the malware is doing. If you do that, you will literally spend the rest of your life trying to work out what each line of code is doing. So you need to kind of like know where to start. And usually for me, I start with stuff that I've seen from a behavioural analysis point of view that I think is quite interesting. And so we know that that host name was interesting, and you can see here it's in the strings already. So we know it's a string that's hard coded into the binary already, and we can just go and have a look at what the associated code to see what the logic was around that host name. But you can see there's other stuff as well, just out of interest, like IPC dollar. So that's probably in relation to how it's going to spread throughout the network. These %d, 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 that's a placeholder for decimal values to go, decimal value dot, etc. That's probably going to be the makings of an IP address. And the reason why there's a placeholder there, I've no doubt that those values are going to be generated probably in some random format. We have %s, which is a placeholder for a string, -m security, so there's some kind of parameter which is called security, so that might be relevant to your analysis, and you might want to have a look around that. The name of a service, looks like, probably associated to the name of a service as well. We've got some API calls, write file, create process. You might want to have a poke around that and just have a look at it. We're going to have a look at this kill switch anyway, so press enter and you go to the portion of code that uses that string. And you can see that's in this subroutine here. And you don't have to reverse engineer every single line of code. You can if you want, but have a glance down it and you can see there's an API call to Internet Open A, and then an Internet Open URL A, and then Internet Close Handle. So basically, if you make a call to that API call, and that's a Windows API, you pass in some parameters here, as well as parameters to Internet Open URL A. When you call these API calls, if they're successful, you'll be returned a valid handle. So you'll first off be returned a handle to the internet connection that you've generated, and that will store itself in the EAX register, which is up here in the general purpose registers. And the same for Internet Open URLA as well. So you'll have a value returned to you in EAX should there be a successful connection to that weird URL. So I'll breakpoint on that, and I'll run to that point in code. Take my breakpoint off. And so you can see here that there's a value in EAX already, and that's the return value from Internet Open A. And if I take another instruction, you can see that it's going to change. So we've now changed the value in EAX, and that's the handle to Internet Open URL A. So what that means is that there's a valid handle to that URL, and so therefore that DNS request was actually successful. And then it moves the value of EAX into EDI for whatever reason. So you'll see the value of EDI now change, and that now reflects the same value as EAX. It just moves that handle there. It closes the handle, and then there's a test of EDI. So there's a test here of the EDI register, and what that's doing, it's going to test to see whether or not the value in EDI is 0 or not. And there's a conditional logic instruction here. So there's a conditional jump. And JNE means jump if not equal to 0. So if it's not equal to 0, that means that there is a value in EDI, and therefore there's a valid handle So if there is a valid handle, it's going to jump, and the code is going to jump down here. If there isn't a valid handle, that basically means that that kill switch has not been activated yet, and no one's registered the domain. Therefore, the code is going to continue, and it's not going to jump, and you'll come down here. Easier to see it in the graph view. So if we press G, we'll go to graph view, and we can see here the calls to internet open URL A, the close handle, the test of EDI, and then the conditional jump. So it's going to go one way or another, depending on whether or not there was a returned value in that in the EAX register, which then was passed to EDI. So jump if not equal to 0, so it's going to follow the green route. And basically you can see it's not doing anything but pretty much just returning from that function. If it is equal, then it's going to come down the red route and it's going to call this other subroutine, which is where all the badness happens. So let's go Alt and C back to our CPU view. So what we need to do is trick the malware into thinking that actually that URL connection didn't exist or wasn't valid. So let's go to the next instruction, which is the jump if not equal to 0. And you can see that x32 tells us down here in the left that the jump is taken. And that's because there is a valid connection. Therefore, the kill switch is activated, so it's not going to infect you. But we can change here the 0 flag in the eFlags register. There's a few ways of patching this. This is one of them. And the 0 flag basically means the 0 flag is set to 0 because the value in EDI is not 0. So therefore the 0 flag is 0 because it's not 0. So if we tell it that it's 0, we can double click the 0 flag, and that just pretends that that test, the result of that test, is 0. So you set the 0 flag to 1, that means it is 0. It's a little bit counterintuitive, but I guess just get your head around it. So now that we've set that to 1, you can see here the jump is not taken, and therefore it's gonna further infect us. Before I do that, there's a couple of things I want to show you before I go and infect myself with WannaCry, which we will do, and I'll show you that from a behavioural standpoint, what it looks like. We did have a look. Let me just go back to what we looked at earlier with PE Studio. One of the things we looked at that came up here was an executable resource, and the name is 1831. It's irrelevant, but that's its name. So why has it got an executable resource? Well, you can dump the resource from PE Studio, but you can also dump it from Resource Hacker. It's another tool just to have in your arsenal. And you can see here, you can see the hex bytes, so 45A, so an executable here. And you can just dump that out and have a look and poke around it, basically. Save it to the desktop. I call it 2.exe because it's the second stage. I'm not really that imaginative. So if you stuck that in PE Studio, and let's have a look, just the basics of your malware initial assessment again. Again, virus total indicators, file header, imports. So there's a few different imports here. So create mutex, etc., all different stuff. And you can see the resources on this one slightly different. It's got a pkzip signature, which suggests that this is a zip file. And indeed, if we have a look, if you wanted to have a look in Resource Hacker again, have a look at that resource, you can see it's pk header. It's a zip file. So if you try to unzip it, let me 7-zip and extract it, it's asking for a password. So this is actually a self-extracting zip file. So when you run WannaCry.exe, it's going to extract this resource and then it's going to unzip it. But there's obviously a password associated to it. So we need to know what that is. So let's stick that into x32dbg. And bear in mind, so let's go to the main resource. I told you what I do. I generally do two things when I load something into x32. The first was have a look in the current module for strings. So that's fine. We've got some strings here. We've got WannaCrypter. We've got read, write file, blah, 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 loads of crypt stuff, etc. And actually they look like Bitcoin wallets. So loads of things to get our teeth into. The second thing I do is I have a look for intermodular calls in the current module as well. So this gives me an idea in the current module what API calls are being referenced in the code. So we know from this one in Resource Hacker that there is a resource in this binary and it's a pkzip, right? So let's go back to make sure we get the right one, 2.exe. It's going to, at some stage, load the resource. So let's look for APIs associated with loading resource. So here we go, find resource, load resource, lock resource. So let's have a look in the code. All of these, quite nicely, appear in one function, one subroutine here, rather, that is up here. So we've got this subroutine, which starts at 401 DAB, calls find resource, load resource, lock resource, size of resource, etc. So what I want to know when it does something with a resource, what's calling this function. So go to the top of the function, right click, and you can see we've got a thing for xrefs here, or you can press the letter X. Click on xrefs, and that's going to show you the cross references in the code. So what part of the code is going to call the function or the subroutine that's going to do something with a resource. And thankfully, there's only one of them, so we can go to that, and it's here. So here's the call to the subroutine that's going to load the resource and do something with it. And we know that it needs a password. And lo and behold, two instructions up from that call, we have a hard-coded string here that's going to be passed to the function. And you can see here, the string is WannaCry at 2017. So if you wanted to, you could copy that out. Let's just copy the selection, copy it to Notepad or whatever. Here we go. So we get that string here. And there's, hopefully, we can try that as our password. Let me just exit that. We'll try and unzip it again. Unzip to 2. Yes to all. Put the password in. So you can see I show password. That's the password. Bingo. This time it's unzipped itself. So that's a little trick there. So if you find yourself dealing with malware that's a password protected zip file, there's a very quick way that you can use to hopefully reverse engineer it and find the password. So you can see that actually there's a number of different files in here that do quite a lot of different things. We don't need to look at them all, but that's not the nature of this video, if I'm honest. But taskdl, that's responsible for cleaning stuff up. Task.se is responsible probably for spreading, or actually the actual ransomware. If you look in the message folder, these are all of the, let's open one in a hex editor real quick. So RTF file with the ransom note, and they're translated into different languages. As you can see, there's loads of them. And then you've got all of these different files here. So what I tend to do is just stick them in a hex editor and have a look and see what they're all about. So b.wannaCry, that looks like a bitmap file to me, looking at the header. So that's probably the ransomware image, or whatever you want to call it. You can probably have a look at that. Let me try and let's see if it's a valid BMP. See if it loads. Yeah, there you go. So that's the actual background that will probably use for your machine when it's infected you. Let me just change it back. .wannaCry. There you go. C.wannaCry is only 1 kilobyte in size, a pretty small file. And you can see here there's some hard-coded Tor addresses, which the binary will obviously use to communicate across. R.wannaCry, what's this one? That looks like the ransomware message again. S.wannaCry. So let's have a look in HXD here, and we can see this is another zip file. It's got a PK header, so you could probably unzip that. Let me 7-zip it, unzip it to S. Here we go. Lo and behold, that's Tor. And so it looks like, without inspecting it in too much detail, it looks like that's a genuine Tor binary. So no doubt it's going to communicate over Tor as well. T.wannaCry. Let's have a look. Looks like some probably something to do with the encryption routine it uses. Maybe that's the key. And then U.wannaCry as well. This is an executable. So I think that's actually the decryptor, if I remember rightly. So the actual decryptor binary. So there you go. That's a nice quick way of, if you wanted to, you could deep dive on any of those and go and have a look at it. So let's exit this one, because we kind of cheated a little bit and unzipped it ourselves, right? What we'll do is, now we're at the stage where we've deactivated the kill switch. We'll capture events again in process monitor and just finish off what it looks like when you infect yourself with the ransomware. So you can see the process here is waiting for me in from x32. It's not done anything yet. And if I press F9 to get the code going, you can see that actually this closes and I get a service created. I've got task sched.exe, whatever it's called. I've got a service which has been created, which you can go and start inspecting. And if I have a look in process monitor, and you can see there's a lot of activity going on here now. So because it's not that clean to work out what the deal is, what I tend to do is press Control and T, and it will bring you up a process tree, so a parent-child relationship, so you can see for yourself what the kind of relationship between all of those processes are, nice and easily. And so you can see here that like x82 launched WannaCry, which we know, and then we ran it. It launched task sched.exe, which is known as disk part. And if there was any command line, you would see it here as well. So you can see flag I. And then also you can see that it's started a separate process, a separate thread. So no doubt it's copied itself to a different location and started running. And you can see here that actually it started running from the C program data folder. So there's a folder that we can go and have a look at. And if you wanted to, I feel like I'm going to get a WannaCry pop-up here any minute. It's going to tell me I'm infected. So let's go to C program data. And I have my views here so I can see hidden folders. You noticed, if I go back, you notice that program data is a little bit kind of faded, and that's because it's a hidden folder. And you can see another hidden folder here, which is the one that they've used. And here's all the WannaCry stuff, right? So we've got like the public key file, for example, the Wanna decryptor shortcut. Here it comes. Here's the messaging. Please read me .text, etc., etc. So we can see that it ran from that folder. It then called attrib.exe plus h, which makes it hidden. It uses ICACLs to grant the everyone flag access to the folder, and then it launches taskdl, which is a cleanup routine. So again, that ran it from the program data folder, which we've just seen. It ran a bat file. Here we go. And here's the message that you get. Familiar message. We've got 24 hours left. We need to pay $300 worth of bitcoins to that particular Bitcoin wallet. Check payment, decrypt, etc. So good old. If I get rid of that, it'll pop up in a minute as well. And it's got a couple of persistence mechanisms it uses as well. So it's written itself to the registry, and also we saw it create itself as a service. So that's a couple of different ways it's going to remain persistent. So no doubt it'll keep popping up, even if I, here we go. Even if I stop the service or stop the service, and it'll come back next time when I reboot. If I stop the processes, again it will continue to persist from the service, whatever. So another thing I wanted just to quickly have a look at. Let me stop capturing events just for now. Just to showcase to you some of the other stuff that you can have a look at from indicators of compromise maybe. We had a look at our filters. If you press Control and L, a process is being created or exiting. Also, what we can have a look at here, there's loads of stuff, as you can see, that you can choose from. But where the operation, I like to see where it's like setting stuff in the registry as well. So you can do reg set value. So have a look for stuff where the registry is being set. And this is going to show you every process, and we'll start to filter down in just a second because we don't know. There's quite a few different process names that our WannaCry binary has managed to spawn. So it's got Wanna decryptor, it's got task sched, and blah blah blah. But we'll see what's kind of relevant to us in just a second, I guess. One of the ones that's just jumped out at me, just from where I was in the code here, on the screen here. So I'm not really bothered about Explorer, so we can exclude that. It just takes a second because there's quite a few events to filter. Services as well. Not really bothered about that process right into the registry or seeing what was as a result, nor is SVC. So you can see WannaCry.exe. So you can see it's actually setting the value of my proxy settings. That process then exited. You can see it then created taskhead.exe, that and then it exited. And then also there you can see that it then ran from the program data folder, and then it set the value of HTLM software WannaCryptor, and it set a value called WD. So if you went to your registry, what was it? HTLM software WannaCryptor. There you go, WD. And it set the value of the folder that it runs from. Now this changes, this is random, so where you see MVUP blah blah blah, that will be different on your machine. It's actually calculated based on your host name and other things like that. And then you can see process creations, all the other stuff that we saw earlier on as well. So that's a good indicator of compromise. I've seen reports as well to suggest that there are, what do they call them, mutexes that are created by the particular sample as well. So if there are it will look in the registry for particular values. I've not seen that in this particular sample unless I've missed it, and it's kind of not jumping out at me. Also, what you can see if you scroll down a little bit further, you can see as well, this is probably quite an interesting command line to note as well. So it VSS admin delete shadows all quiet and WNIC delete shadow copies, etc. So it's gonna delete all of your volume shadow copies And again, that's to make sure that you can't restore your files from backup. And also you can see here's the second, where the reg set value of interest as well, where it's set itself as a persistence key in the software Microsoft Windows current version run, and it's just made an entry for itself there from the program data folder that we saw earlier. So again, it starts itself as a service. It also installs itself into this current version run key, and there's this persistence mechanism. You can also see as well, it's set the wallpaper to be the bitmap that we saw earlier on. So no doubt, if we go to our desktop, indeed we can indeed see that it's changed already, and we've got the infamous WannaCry message on the screen. So that's WannaCry. That's how you'd analyze it from my point of view. You can also actually see, I should probably mention as well, in terms of Microsoft Netmon, just to finish up, you can see the network activity. So nice and easy, which is why I like this over Wireshark. You can easily see, from the process point of view, what process was responsible for what traffic. I always get sick of Wireshark because I never know what's malicious traffic and what's not. I've got Google Update. Well, that's not malicious, but all of this noise would be in my Wireshark view, and I can't be bothered coming up with a filter to filter it out. This does it nice and easily for me. Task SVC, you can see here. So there's like 5 IP addresses that have been communicated to by the malware. So again, if you wanted to, if you went into the code, you'd probably see that those IP addresses are actually randomly generated. So you could look for that kind of activity in your environment if you saw signatures like that. If you saw a process communicating over Tor, that's probably something you would want to inspect as well. But anyway, those are the kind of tools and techniques that I would use in order to analyze the malware, get the indicators of compromise from it, and really kind of pick it apart. So hopefully you find that useful. Hopefully you don't get infected with WannaCry, but if you do, hopefully you know how to reverse engineer it and recover from it, all being well. Thanks, guys. Hope that's useful, and see you soon.